Okay, here is the problem 3 on the sample test. What we know is that 1.5 kilogram mass is suspended motionless from a spring, and at that point the spring extends to 2 centimeters. So there is a mass suspended on the string. It is extended, the spring is extended from its usual, from this, when the mass was not applied. Compared to that, the string is extended by 2 centimeters. Okay, so there are of course forces which act on that mass. There is force of gravity, and there is elastic force. They have opposite directions as shown in this diagram, and the system is motionless. It means that it is in the static equilibrium, and one of these conditions of the static equilibrium is that the net force, well, in this case in the y direction, is 0. Okay, so we can just write it down. What the net force is, it is elastic force, which is given by k times this length over here, the extension. So it contributes with a positive sign because, as I showed here, it has a positive direction. So it tries to bring the mass up. Minus mg. Minus sign is because this force has opposite direction to the y-axis. So this is the origin of this minus sign, and in the sum it is 0. And this I can solve for k. It will be mg divided by L. I can substitute the numbers. All of them I know. It is 1.5 kilograms times 9.8 meters per second square divided by L, which is 2 to the negative 2 meters. Using my calculator, I obtained 735 newtons divided by meter. Okay, so this was the first part. I wanted to find out what the spring constant is, and now I will apply that to the next part of this problem. And to the next part of this problem, it is said that after this, after the spring was in this stable equilibrium position, it was pulled down a little further. So it was in the stable equilibrium, but then we pulled it down even further. Okay, and then this mass will start to oscillate back and forth with some amplitude. And the amplitude of this oscillation is given. So the amplitude of this oscillation is given by the additional pull over here. So this distance, it is 1.2 centimeters. Okay, so the amplitude is 1.2 centimeters, or 1.2 times 10 to the negative 2 meters. Okay, what we need to find is maximum acceleration. We know the equation that the maximum acceleration is given by a times the angular frequency squared. The angular frequency for this elastic system, okay, which is a times k over mass. So it was, the omega is the square root of this, but we need omega squared, so we need to find this, and therefore it is just k over mass. Okay, we found k before, so we just substitute all the numbers. It is 1.2 times 10 to the negative 2 meters times k is 735 newtons divided by meter, and everything is divided by the mass. It is 1.5 kilograms. And now we can do this calculation. to obtain 5.88 meters per second square.